All right, guys, this is going to be our first video on a broad topic called kinematics. And in this video, as you can see here, we're going to be talking about two kind of fundamental concepts that will be with us for really most of the year, which is on the one hand, displacement, and on the other hand, velocity. Velocity is probably a fairly familiar word, maybe displacement isn't, but we'll get to it. Before I do, though, I might just might be worth kind of zooming out for a minute and noting that this is all of this is under the broader heading of something called kinematics. So this is all about kinematics, which is a fancy physics term for the study of moving objects. How do we use math to talk about moving objects? That's what kinematics is. So we're gonna have several videos and at least 3 units that encompass kinematics. And this is our first video, and we're talking about maybe some of the most fundamental concepts here, which are, again, displacement and velocity. So let's get to it. So displacement, I'll start there. Displacement is related to a more familiar word. So maybe I'll write this. Displacement is related to the more familiar word, which is distance. So maybe to illustrate the difference between these terms, we could imagine we have a road here. So here's a road, let's say right here. Maybe we'll make it a black road rather than a blue road. Here's the road. And maybe we have on this road, we've got a person running. You're going for a run on the road, let's say. So where's you? Here, we'll put you right here. We'll make you blue. So here you are, running on the road. There you are, going for a run. And we're going to imagine that you start right here. This is your initial point. And to allow us to talk about this more simply, I'm going to imagine that this road is actually an x-axis. So we could imagine that this is an x-axis. And I'm going to determine that to the right we'll call is the positive x direction. So this point right here is your starting point, which we will say then is x sub I. And the sub-index I, this just means initial. So x sub I is your initial x, or your initial position. So your initial position, x sub I, let's just, for simplicity's sake, we'll call this 0. That's your initial starting point. You start at 0. And I'm gonna have you running here. You're gonna run, first of all, we'll have you go in the positive direction over to, let's say, x final is, let's call it 10 meters. So this is x initial, this is x final, so this is your final position. And, I could ask you, well, how far did you run? What is your distance? If I asked you how far, that's a distance. And it would be pretty obvious that you ran a total of 10 miles. You started at 0, you ended at 10, so your distance here would just be a total of 10 meters. We'll use meters, by the way. That might be a slightly less familiar to some of you unit, but that's the one that we're going to be using most this year. So I'm going to stick with it. So we'll say that's 10 meters. You've run a distance of 10 meters. And what we would say for your displacement, what does that mean? Well, your displacement has a very precise definition. If the distance is just how far you went, if we think of this as how far, the displacement is going to have a more definite definition, which is we're going to say it's the final position, x final, minus the initial position, x initial. So rather than how far, this we could say is the change in position. Now, what's the change in position here? Well, in this particular case, it is 10 minus 0, which is positive 10 meters. So in this particular case, they yield the same answer, right? We have the distance is 10 meters and the displacement is 10 meters. we're just going to go ahead and put a little box around this displacement. Actually, maybe it's better to just highlight the thing. This I'm going to highlight because that's actually an equation. The displacement, this is the definition of displacement, final minus initial position. So again, this is a particular problem where the position of the displacement and the distance are the same. So you might be asking, well, what's all the fuss about? Well, there's some situations where they won't be the same. So now we could imagine maybe the same situation. Maybe I'll draw another road down here. We could imagine now, here's the road. Here's the road again. And we'll have it be an x-axis again. And I'll put you on that road. And so here you are, running on the road. Yay. And once again, we'll have your x initial be 0. And then maybe what I'm going to have you do is I'm going to have you run all the way over here to x equals 10. And then I'm going to have you, after you get to this point, you're going to turn around and you're going to run now in the opposite direction. And you're going to end up at x final equals -2. So it's sort of 2 legs of the trip. The first thing you did is you ran in this direction, stopping at x equals 10 meters, turning around and then running in the opposite direction and ending up finally at x equals -2. So now I would ask you, what's the distance? And you could probably sort of intuit what this is going to be. Right? You ran 10 meters this way, 10 meters back, and then an additional 2 meters. So the total distance you covered here is 22 meters. Okay, that's the total distance. So 10 meters this way, a total of 12 meters that way gives you 22. That's the distance you ran. But your displacement, if we go back to this definition, x final minus x initial, right? This definition up here, x final minus x initial. The final is -2 and the initial is 0. So we're going to get a displacement now of -2 minus 0, which leads to -2 meters. So we get a very, very different answer here for the displacement than we do for the distance. One last thing I'm going to mention on this, I think hopefully by now you're getting the hang of this. I'm just going to mention that displacement is abbreviated since it's x final minus x initial, we abbreviate this with the symbol delta x. Delta x. So maybe actually I'll go ahead and write that down here just to make this a little bit neater. I'll say the displacement, which is delta x. And in general, in this course, whenever you see this little triangle, this delta, it just means change in. And the delta x is defined as x final minus x initial. And that's our definition now of displacement. This is displacement defined. We did it before, but we're doing it again. So here's the definition of displacement. So hopefully you got the hang of that, the difference between displacement and distance. So let's talk a little bit about velocity. This is a more familiar term. And you probably think of velocity when you hear that word. If you think of anything, you probably think of a related but different term, which is speed. In fact, you may have thought velocity was just another word for speed. Velocity is not, in physics, another word for speed. So maybe we'll just start with the definitions of these rather than working our way into it. I'll just define them for you, and then we can kind of see how they're different. Speed is probably the more familiar term to most of you. Speed is defined as the rate at which you move, or the distance divided by time. That's distance divided by time. That's a familiar term. So speed here is related to distance. Speed relates to distance. You can probably see where this is going then. What is velocity? Well, velocity isn't distance divided by time, it's displacement divided by time. Okay, so this is now velocity, velocity has to do with the displacement. So for instance, if we were to go back to, let's say, this particular case up here, maybe this total trip here where you start at x equals 0, you run in this direction 10 meters, turn around, and you run 12 meters in the opposite direction. Maybe we'll say that this whole thing takes 2 seconds, maybe the total time here. So I'll add in a little bit more information now. I'll say the total time. Maybe I'll kind of move this over here and write it this way. I'll say total time is 2 seconds. Okay, so if it takes 2 seconds, then what I could say is that the speed then, what would that mean? That would mean that the speed is distance over time. That would be 22 over 2. And what does that mean? Well, 22 over 2 would be 11 meters per second. Okay, whereas the velocity, what would the velocity be? Well, that's the displacement over the time, and the displacement we said was -2 meters, so it would be -2 over 2, which is -1 meter per second. Now, so I hope that distinction makes sense to you here. One thing I'll point out here, when we're talking about distance and when you're talking about speed, when you're talking about distance and when you're talking about speed here, distance and speed, there you will never have a negative number. Distance and speed never take negatives. They're, in a sense, it's sort of like, you can think of it as an absolute value if you like. Whereas displacement and velocity, absolutely, as we saw in the previous examples, displacement and velocity can both be negative, because in displacement and velocity, the direction that you move matters. And that's relevant enough that I'm going to write it down, actually. So displacement and velocity include direction. Direction matters. And for now, we're going to think of the direction. When we talk about direction, we're only going to think of it about it as positive or negative. You could imagine there's other ways of giving directions. It could be north or south, east or west, left or right. There's a whole bunch of different ways you could think about it. But we're just going to, for now, mathematically, for the time being, think about it as the positive direction or the negative direction for the time being. So moving on, we're moving on from this video. From now on in, for most of the course, we are going to be thinking about these two concepts, displacement and velocity. These are going to be our key concepts here and here. These are going to be our key concepts. We will not as much be talking about distance or speed. Those terms might come up a little bit, but primarily we're going to be building off of displacement and velocity.